Our next speaker, Sergey, is a software engineer and a blockchain expert with a strong background in physics and mathematics from Saint Petersburg State University. In his talk, Sergey will share insights from performance testing high-load systems, including practical approaches to asynchronous testing and the development of custom load generation tools. Ladies and gentlemen, please give a warm welcome to Sergey.
Hi, everybody. Thanks for joining my talk. I'm excited to be here, and firstly, thank you for your attention. Today, we talk about performance testings. I think it is a difficult problem, and I'm trying to share my experience from several projects, and I think it will be interesting for you. Give me a second. OK. Sometimes it's boring to present yourself, but a few words about me. Nowadays, I'm a backend engineer. My responsibility includes managed teams, create architecture, selecting programmers, code review, and of course, I want to be sure that my system works correctly. Firstly, I want to say about our system. Our system, it's microservices system, includes many various functionality, many blocks, models, and sometimes it's difficult to understand that your system works and robust. And of course, testing takes the important part in our system. Firstly, let's say about how to preparing our system for real-world demands. What about scalability testing? If we increase our hardware capacity in several times, we want to be sure that our system increases linearly. And if our system increases linearly, that our realization is good, and we can roll down this realization to prod version. The second part of testing which we use in our development is spike testing. I think it is not very interesting, but sometimes you should understand that system can handle spikes. And you can fetch some faults from this system. Of course, commonly we're testing before your system potential, and our test case contains maybe 10 or 5 spikes with different configurations. What about stress testing? Stress testing, it's a very interesting type of testing because you constantly increase load and you are waiting when your system fall down. And sometimes, of course, if you create a robust system, it maybe takes several hours. But it's very useful and test for maybe for nights or maybe for a long period. And the last type of testing which we are constantly using is volume testing. I know that spike, soak testing, load testing, it's common, but volume testing, it's another type. You can understand that your database maybe works very perfectly, but what about large data set? Maybe you have problems with indexes, maybe problems with database queries, and you can fetch this information too. So how to prepare your environment? Some small problems which we know. Firstly, it's dependencies. We constantly scan our dependencies packages because it can influence on your test results. And keep in mind that you have actual versions in models. You can see here that low, critical, high, medium issues and you can track. It's very useful. And sometimes you have some correlation between, between dependencies issues and your test results. Yes, one little story about testing in developer machines. Of course, the main problem is unnecessary software which influence on your results, test dynamics. And second problem, it may be the most important problem, it's environment, different environments between prod version and developers testings. Sometimes my developers can say, "Oh, Sergey, don't worry, it will be okay. I am testing. It takes 5 minutes, and we can research these results." But keep in mind that constantly these results cost nothing, and you should have some special environment for tests, not developers machines. Yes, and so remember about background jobs. It was the second story when we run tests with small changes, and we want to increase our speed for services, but we get unexpected results. And problem it was in background workers and jobs. You can planning, you can considering your prod jobs and switch and get correct points for your testing. So we use many tools for testing. It's the Gemeter, K6, Getlink, our custom tools, simple tools such as VRK, Apache, benchmarks. But we choose only two interesting tools for us. It's Gemeter and K6. K6 I say maybe later. Firstly, you know that it's flexibility. You can using our protocols, not only HTTP protocol, because we have microservice structure and we have many communication between services in gRPC. Sometimes we're using web sockets in testings, and so flexibility is useful for us. Of course, metrics. GUI Geometer GUI can give you good results, graphics, charts. You can understanding maybe some problems. Of course, it contains Spike, SOC, performance testing, and of course, it's a robust system with good community. It's no problem to integrate Geometer to your CI/CD, continuous integration, and fetch results very quickly. It's very common chart. You can see here that system is stability, and you can see yellow points that you can understand that you have some problems with your data, and we adjust caching and database queries and minimize our latency. But sometimes it's difficult to interpret charts, especially if you run many tests. You maybe get not beautiful or gorgeous charts. What about hidden pitfalls and problems? Firstly, when you're using such a robust tool, you should understand that you pay in memory coins. And you can see a comparable table that Geometer, it takes approximately 500 memory usage. For example, K6, it's less than several times. Okay, what about K6? K6 is very cool tool we're using in several cases. What we want to get from K6? Firstly, it's very flexible scripting. You can integrate in your scripting generating API and using your special maybe generating data. you know that K6 works with Prometheus and Grafana, and they have good integration. And they have InfluxDB. And performance benchmarking was very great for us. And for quick test or maybe some difficult testing, we're using K6. What about problems? Firstly, we have problems with their InfluxDB integration issues. Sorry. And sometimes, maybe it was our programmers' problems, I don't know. But sometimes we have problems with their DB, and you don't. You should to understand it, and maybe we can't know how to cook it, DB. It was problem with very large data when we're testing our database. And maybe the last problem, long pending pull request for community libraries. Sometimes it's more easier to switch another solution. Yes, it's a comparable table. You can see all our testing tools. It's maybe for us, it's maybe for us important speed, metrics, flexibility, and simplicity. For maybe something simple, one endpoint without difficult protocols, you can using Apache or VRK. It's very simple speed, but don't have metrics. Of course, JMeter flexibility, but has low speed if we comparing with K6. And don't forget about some custom tools. Of course, it's flexibility, speed, and have huge metrics, but development takes many hours and sometimes several months. So what else we have in our testing arsenal? We're using Allure for testing our models. Have JUnit 5 for testing. Have database generation and testing database. So commonly we have some tests for each model. And using K6 and JMeter for testing communication between these models, and using K6 for our other various scenarios and finding issues. So a little bit about our infrastructure. We're using Google Cloud Platform because we understand that it's more easier for us and run this whole system with Google Cloud Platform without problems. But with Amazon, we have several problems. It's very fast. We don't have problems, and it works more than 1 year without some unexpected errors. And so we look that it's a good decision for us using this infrastructure with K6 and JMeter. So what about some small story? Developers can create both fast and slow services, but only using testing you can identify the difference. Sometimes it's difficult to find a difference between your test cases, and so we have some practice to compare our results with previous results. We have some history which takes maybe several months, and we can understand degrade our system or not. We have some ideas to maybe create some mathematical tools for this history, to comparing other models and system scenarios, but nowadays it's manual. Okay, it was very quickly. Thanks for your attention.
Thank you, Sergey. Any questions for Sergey? You can also ask through the Huva app. Any questions in person? Going once. Okay, there's one. Question is, why so many tools?
Huh?
Why so many tools?
Why so many tools? Because we want, of course, we have several test developers, and each developer wants to integrate his own tools. And so we decided to compare all tools. And when you have a microservice structure, you can apply other tools for other models without problems. And so we have some maybe challenge to comparing and find good decision for our system.
Thank you. And another question is, how do you perform volume testing?
What?
How do you perform volume testing? Volume testing.
Volume testing. Volume testing. It's one big area. We're using small database and big database. And firstly, each service has own database structure, and we want maybe to indicate database issues, indexes firstly, because we have complex product with various tables, and sometimes it's difficult to generating information for database. And so we're using our own generator, and in many cases we find problems with database queries. And so volumes we're using firstly for optimizing database queries and research how many requests can handle our service with database, something like that.
Thank you. There's another one. What is the total execution time of all your tests?
Sometimes I'm crying. It takes. It depends on situation. We have tests for prod education, for prod environment. We have tests for each model. Some difficult test takes maybe 1 day, approximately. But we run this test at night, maybe, and we can fetch some results maybe in middle of the day. But sometimes, as I noted, my programmers can run tests for several minutes, but this test costs nothing.
Okay, thank you. We have a couple of more. Where do you run JMeter/K6 tests from? And how does that machine specification impacts test?
Machine specification impact test?
Yeah, so where do you run JMeter/K6 tests from?
Nowadays, we run K6 and JMeter in CI/CD. We include our system directly in our continuous integration. And we have some scenarios for K6 after each commit or changes. And JMeter, it's manually in GitLab.
And how does that machine specification impacts test?
Machine specification impact tests. We have, we don't run tests in our, we're trying to avoid run a huge test in our environment. We're using the empty machines with generating data to testing our system. And so we don't have many problems with, in fact, in our hardware, if I understand correctly question.
Yeah, if not, like someone will approach and ask. And one more, what is the maximum number of clients or requests you're typically simulating in load tests?
We're trying to handle from 500 until 1,000 requests per second. But it depends on system, depends on models. Some models have more big load, and it maybe increase 2,000 requests per second. Of course, some models don't have good speed, but we work about it, and we think to maybe in this quarter we can optimize some models.
All right, thank you. Any questions in person, maybe? All right, if not, you can meet Sergey after the talk, and we'll see you back here in 3:15. Thank you all.